So variations and parameters. So this section is about the same as what we've been doing so far. However, what if it's not in this format and sine and cosine? And the other thing is, well, when it came to our general format and our particular equations, we always had constants in front of our terms. But what if instead of constants, they were functions instead? That's what the variation parameter represents is, okay, what if instead of C1 and C2, they're V1 of t and V2 of t? Now they're functions in terms of t of that process. So that's what we're going to be dealing with in this case, right? So the variation parameters is a very long and lengthy process how we do it. But it's the same process as if, this is, just functions themselves, plug it into as differential and just solve for each one individually. However, since we have two V1 and V2, we're going to have a system of equations. So here's our system of equations we have to solve accordingly. Now the problem is each one is derivative. So when we solve for the system, we solve for v prime of 1 and v prime of 2. So the actual derivatives. So we still have to take the integral of it. So what I end up doing is instead of, you could technically solve for a system of equations, or after a lot of straight out algebra and solving for each one individually, you can use these equations there. And then eventually just take the integral of both sides, right, for v1 and v2. Okay. So solving for a system ends up giving you these equations anyways. Okay. So just one or the other, we'd like to do so. Okay. Now, when it comes to the method of variation parameters, the biggest thing is the first part is the homogeneous part. The second part is f over a. So the a value is always in front of the y prime, or y double prime, or the second derivative. And obviously the f is going to be what's equal to itself. So the latter part here, or represented there if you want to use the equations, is the a value always in front of y double prime. Okay. So once we follow that process, we just straight find v1, v2, and that's going to be our partial solution, and that our particular solution. And that's the key thing. It's only our particular part, not the actual overall portion, which is, unfortunately, everything we have to do so. Okay, so we still have to actually find the homogeneous part, plug it in, and eventually get the actual whole equation itself. Okay, but this part is all about how do we finding these two functions themselves. Okay. So let's try a couple examples out. So for the first one, we want to find the general solution within the interval from negative pi over 2 to pi over 2. Okay. So because we want the general solution, unfortunately we have to do the long way, meaning we have to find our homogeneous part and then plug it in itself. Okay. Okay, so that corresponds to going back to our characteristic equation. So we can get imaginary numbers. So in this case, r is equal to 0 plus or minus I. We'll follow that format. That way we can use this process here. Okay. Okay. So according back to our sections, so for our homogeneous part, because for our general solution, we have our particular plus our homogeneous part. So I'll just write it as for our homogeneous part, y of h. Since it's, in this case, r is 0, it follows that portion. So it's going to be y1. Well, yeah, I guess I could just do it that way. So this is going to be considered y1, and we'll consider that as y2. All right, so the question now becomes how do we follow, or how do we find this v1 and v2? Okay. Okay. So first off, again, you could do two different ways. You can solve for the system of equations, or you can just use the equations themselves. Either way, you got to get the same answer. However, sometimes solving for the system goes a little faster, or it's vice versa. Plugging in the equations is faster than actually solving for the system. Again, depends on the situation at hand. Okay. So in this case, we're just going to break down. I'll use the actual formulas to since it's sine and cosine, you'll see it actually ends up being nicer. So first, so we get those portions, and according to our equation, v1 prime is going to equal to, and well, we need these derivatives anyway, so just write them here. So the derivative of cosine would be negative sine, or yeah, and this is going to be positive cosine. So now we're just going to plug it into our equation. So v1 prime is equal to the top. In this case, my f is going to be tangent. So it'll be minus tangent times y2, so sine. Okay. In the bottom, it's a, and the value in front of y double prime is 1, so I'll just leave that 1 first for general sake. And then just follow the pattern. So first number here is going to be, let's see if I could keep it here. So it's going to be y1, so cosine, times y double prime, or no, y prime 2, so cosine, okay, minus this, so that ends up being, I'll just put it up, but it's going to end up being a positive, times y2 sine. Okay. All right. And now we're just going to simplify as best we can. The best part is this becomes positive. So cosine squared plus sine squared, that's a famous one. It just gives you 0. So v1 prime is equal to negative tangent sine. Okay. Now if we do the same thing for v2, just since we're on the same format, now I'm just going to follow this equation. So it'll be tangent times cosine all over about the same process. So y1, so cosine times cosine minus, and the best part is if you notice it's the same on the bottom top. So again, ends up being 0, so this is just that. Okay. All right, so now it ends up being just how do we simplify this process? Okay, so we'll do the easier of the two, since a lot of those cancel out with tangent and cosine. Since tangent is sine over cosine, the cosines cancel, and therefore this derivative is just sine of t. Okay, so we'll just do that one first, since that's easy to do. So integral both sides. So this just ends up being negative cosine no plus c, but you know the plus c will get devoured. So that's the first part. Now let's talk about this one. All right, so this one is not as fun to deal with. Okay, so when I convert this, this is now going to be sine squared over cosine, and we know that again that's true. So a little side note here. Okay. And if I solve for sine squared, I just bring that over. So this ends up being 1 minus cosine squared over cosine. Okay. And now I can split up this fraction. and eventually I just get that. So that's a much nicer, easy way to integrate. And this just ends up being secant. So much easier to deal with. Right, so taking this integral, so integral of secant is ln of secant plus tangent, and integral of cosine will be sine. And the best part is the minus, so it goes away. Okay. So there we go. So my general solution, well, let's talk about our how it's going to be formatted. So this is just the particular solution we're just about doing, right? You have to add on the homogeneous equation at the very end, or just add it on here. So if we go back over here, our general solution will be the first two from our homogeneous part, and then plus, this is where this comes into play. That part right there. So it's going to be V1 times this, and then V2 times that. Okay, so V1, which is all of this, times Y1, plus that times that. And again, those do cancel, so it ends up being, after you simplify that whole part there. So I guess they cancel there. So that would be our general solution. A lot to do. Okay, so what if we just want the particular part? So in other words, let's just do half of it. So let's just find this half, not including this half here. So that's the second situation here. So just find the particular solution to this. Okay. All right, so we did this earlier, and the best part is we can use superposition, meaning I could just split them up and just already know that aspect here, right? So we're actually going to have two parts of this portion. So the first part's already done for us. We found that. So the particular part for just this here will just be that. Yeah. All right. And this doesn't look correct. That's good. Yeah, that's right. The secant part, yeah, okay, good. Okay, that goes there. So now we're just going to go this process. So in other words, 3t minus 1 part. Okay, So this goes m is equal to 1, r is 0, and if we go into our process, this is just like above, we get imaginary. So these are not roots of it, and since m is 1, it's going to be a1t plus a naught raised to the e to the 0t power, which is just that. So this is our y, and then just working our way backwards. So taking the derivative, take it one more time. And then plugging it back into our portion and make it set it equal to this, we eventually get this process. So that means a1 has to be 3 and a0 has to be -1, which is ironically the same thing. So finally, we have our particular solution. It is this whole thing plus all of this. So it's right here, so there we go. So let's try another example. This time, however, let's do half of the work. Meaning, what if we're already given two solutions? We don't actually have to find them this time. So we're given t squared and t to the third are solutions to our characteristic equation. Okay? And here is our equation. All right, so this time, it doesn't matter which way you do it again. Your book does it using the system, just I guess to give you an example. But I'll use both just for practice sake, either way. Okay. So first way I'll just do the system way. The second way I'll do the equation way if you want to do the algebraic portion. Okay. All right. So this one, however, we have a little things to deal with. So f is 4t to the third, and a is t squared. Okay. All right. So y1 is t squared, y2 is t to the third, and we need a couple things anyway, so we'll just take the derivative. Right. Okay, so if we use the system of equation way, this is going to be our template. So v1 prime, so just times y1, so it's going to be t squared, plus v2 prime times y2. Okay. And now the bottom times the derivative of y1 times the derivative of y2. And now this time it's going to be f divided by a, so This divided by this ends up being just 4t. So here's our system of equations. Okay. All right, so solve for the system. Elimination, substitution, probably you don't want to do graphing, right? So let's see what we can do. I guess what we could do is we could multiply this by -1 and this by 2t. Or actually, sorry, this by 2 and this is by -t. Let's do that. Yeah, let's do that. So we multiply this by 2. Multiply this by -t. And then bring everything down. These cancel. Adding these up give you a negative. Dividing this over and just get rid of the negative. So we get this is equal to 4t to the -1 power. Okay, good. So we got that. And now we just work our way backwards to find v1 prime. Right? You can plug it anywhere you want. I'll plug it in here if you like. So if you plug this in, you can just get squared. So subtracting this over and dividing by the t squared, we find out that v1 prime is equal to -4. And there's our system. Okay. So once we have that done, now we just go straight to the integrals. So v1 is going to be equal to the integral of -4, which is really nice because it's just a function. And same thing over here. Okay. So this ends up being -4t. And this ends up being 4 ln of t. So our particular solution, is equal to, and then we go back to our process down here, v1 times y1 plus v2 times y2. So these two plus those two times. So -4 times t to t squared, t to the third. This times this. And there we go. So that's using these elimination method and substitution method if you wanted either way to do it. You could have done the same process, either way, so I start you guys off for that one. So in this case, we just follow our equation. I don't think I'll be able to put it all in one, but you guys get it, the picture. So -f, so -4 t to the third times y2, and our a function is t squared. So on the inside we have y1 times y2 square prime, and then this one times this one. So notice things actually kind of simplify nicely. So I won't simplify the t's just yet. You'll see why. This is ends up being the thirds, or sorry, fourths. So 3 minus 2 is just 1. This gives me 6. And we got the same thing as we had last time. There. And you get the same process if you do for that as well.